Right, welcome to yet another video. Today we are dia question 6 together. Ye longoreng e wela under topic ya doppler effect. Statement sarna sere, the alarm of a vehicle parked next to a straight horizontal road goes off, emitting sound with wavelength of 0.4 meters. A patrol car is moving at a constant speed on the same road. The driver of the patrol car hears a sound with frequency of 50 hertz lower than the sound emitted by the alarm. Take the speed of sound in air as 340 meters per second. So before ka attempt go araba di questions, a re thomeng pele ka go analyze this statement, re kgone go approach with better understanding. Alright, re lemoga gore re na le koloi e leng gore it is simply just parked next to the road. Again, then much as that car is parked, it is also emitting sound with wavelength of 0.34 meters. That car ke car A and it is parked. So hello car A is parked. So re expect the waves in this way. And remember, this one is the one yellowing, it is emitting sound. And the moment something is being emitted, something is actually being released. But release a sound, and the very same sound, it will be heard or detected by someone else. So because the statement suggests emitting the sound with wavelength of 0.34. So error nkata my wavelength ka fetsa ka bia s, why ke bia s, because erroring that wavelength here the source, and that source is actually doing what? Is actually emitting. So when at the moment over the word emit, king tailoring it can emit ke the sound source. That's why when I lambda ke to ba lambda source. Why give you a source? Because sound waves are being emitted. Emitter or emitter the source. Okay, I hope that makes sense. So erroring wavelength the source will be equals to 0.34 meters. Okay, then here a patrol car is moving at a constant speed on the very same road. So error in that patrol car B. So because the patrol car is moving, the waves straight so pattern straight so it will depend if the car is going towards or is going away to that A yaren. Okay, so is it going to go towards or away now? So let's continue reading. A patrol car is moving at a constant speed on the same road. The driver of the patrol car, remember patrol car hears a sound with frequency of, remember I hears, the person is actually listening, the person is actually detecting, right? The patrol car hears a sound with frequency of 50 hertz lower than the sound emitted. The moment examiner lower than the sound emitted, then we can conclude that we are actually the patrol car is actually moving away. Okay, so this is just one of the conditions. Examiner the patrol car hears a sound with frequency of 50 hertz higher than ring over FL greater than FS, and this was going to be moving towards. Okay, so I hope it makes sense. Take note to the next time examiner kataring higher than the frequency detected or heard higher than the frequency of the source, then it will be towards. But since the frequency detected is lower than, it implies the patrol car is actually moving away. So pattern because it's moving away, pattern over this way. Okay, all right guys, my drawing is very bad. So yeah, I have these two scenarios. da 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 go sana ntho a go tshwenya. Then the speed of sound in air is 340 meters per second. Okay, so I hope scenario tse ko go tolotšeng tšona di re make sense. Remember, ye ke alarm ile rena e le goreng e dutse godimo ga koloi ye e leng goreng it is stationary, right? Then ka boa gape ka ba le the patrol car ye e le goreng we were able to deduce or it is actually moving away from that alarm. Why? Because the frequency detected is lower than the frequency of the sound source. Okay, then 6.1 state Doppler effect in words. Guys, remember the definitions from the exam guideline. I'll just write it down for you, then take it from there. Then there it is. Is the change in frequency of the sound detected by a listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Then 6.2, is the patrol car driving towards or away from the parked vehicle? Give reason for the answer. So remember, already re kgonne go choose gore the patrol car is moving away from, right? You just tell the examiner gore away from, right? Then give reason for the answer. Ge we fa examiner the answer, we can easily just tell him gore because the frequency detected is less than the frequency of the sound source. Then yare calculate the frequency of the sound emitted by the alarm. So this one is a free 3 marks. Remember, I calculated the frequency. Remember, I calculated the frequency of the source, right? So frequency of the source is equals to velocity over lambda s. Then frequency that 340 all this divide by 0.34, right? Then the answer will be equal to 1000 hertz. So take note, every time ukishimisha this equation, uberekisha this equation, more being v, we are always going to plug the speed of sound in air. Okay, so sometimes examiner can trick you out of the velocity page. Most of the learners, they get attempted or like that other velocity or maybe the source was going with, or maybe the listener was going with molar. Once you change this equation, molar being v, look at the speed of sound in air. All right, patrol car moves a distance of x meters in 10 seconds. Calculate the distance x. This one is very easy. Remember, since the car is moving away, then we are going to write the Doppler effect equation. Let's normalize to write the original equation first, right? Plus minus vs then fs. This is the original equation. So we are going to score a mark, either like with this, the next step, but oxalayo with the first step rather we scored ourselves a mark. Then with the second step, remember later we are moving away, meaning if we move away, the negative aga santse be ka kae e be ka godimo, then ka fase ke shale ke na le positive, right? So if we are moving away, formula rena re teng wala in this way. But please make sure on wala formula ya gago the original one first, then after we can manipulate so remember guys, this 1000 is the frequency of the source, right? But what about the frequency detected? The examiner on the statement said the driver of the patrol car hears a sound with frequency of 50 hertz lower than the sound emitted by the alarm, meaning frequency detected will be equal to that 1000 that we got up there minus 50. then the answer will be 950 hertz. So surely then our FL is actually less than Fs. So we are simply going to substitute this 350 where we see FL and 1000 where we see Fs. Then mola re bona di-feature tša rena ke speed of sound in air, then over 350. Remember the velocity of the listener arna yona listener arna ke the patrol car ke re nyaka, but the source is what? The source is stationary or it was parked, then re go bja 0. Frequency of the listener na le kana 950 equal to then 340 minus VL. All this divide by 340, then plus 0. Where give you 0? The source was packed, right? Then multiply by what? By 1000. Okay, so ntinga idela mathomo go multiply both side of my equation ka 1000, right? I mean ka not 1000 nka. So to solve this equation, nka multiply both sides by 340, multiply by 340, so that this 340 and that 340 dinchane, then kam kishala kinalo kai le 340. So since the 340 are dinchane, I can erase them, then kishichika equation ya over. So I can divide both sides by what? By that 1000, divide both sides by that 1000, so that this 1000 and that 1000 dinchane, then there they are gone. Then let's punch all this in the calculator and see how much we get. Re humana gore e lekana le 323 equals to 340 minus VL. Then I'll take the 340 kaisha to the other side, meaning Gitori 323 minus 340, meaning Gushala Kenale negative 17, which will be equals to negative VL. Then my velocity of the listener will be equals to 17 meters per second, right? Then remember, examiner baila rorna are calculated the distance x. So to get the distance x, re a tseba gore equation ya rona le kana le delta v equals to change in x over change in t. Then I can substitute mola re bonang velocity re go lokela that 17. Then I'm looking for delta x, then nakwaka 10 seconds, then therefore delta x yaka will be equal to 17 multiplied by 10. Then the answer the examiner is looking for itlo lekana le 170 meters. Then this is the answer the examiner is looking for. I hope the make sense. See you on the next one.